So let's finish up what we started yesterday. So we're going to evaluate trigonometric functions part 2. I just have a little piece left to tell you about, but I want to give us some extra practice on the unit circle. All earbuds out, all phones away, everybody sitting up, ready to go, all the way up, Caitlin. All right, so I'm going to do my benchmarks first. This is 0 pi, comma 2 pi. This is pi. What am I going to do next? Half pies. Here's a half pi and a 3 half pi. I'm going to do my bow ties next. My bow ties are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. I'm going to go ahead and get finished up, I'm going to get finished up with my other pies before I do, I'm just going to keep it with this, my blue. So all that's left up here is pi over 3, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. Questions? Okay, let's do the 45. Again, start with 0 pi and 2 pi, and this is pi, pi over 2, 3 pi over 2, and then I just have to go around and do pi over 4, 3 pi over 4. This is, if this is 3, this is 4, this is 5 pi over 4, 6 pi over 4, 7 pi over 4. You guys ready to do it? Okay. Let me do this first, and then we'll do it. All right, let's just review. 135, second quadrant. 135, reference angle, 45. 7 pi over 4. What quadrant is that? Show me on your fingers. We're getting there. We're getting there. Most of you are saying 3 or 4. If 8 pi over 4 is all the way around, wouldn't 7 pi over 4 be here? And it's got a pi over 4 reference angle. Negative 30 is in the negative direction 30. So that's negative 30 degrees, and its reference angle is also 30 degrees. They're both the same. And finally, negative pi over 2 is here. And it has a reference angle of 90 or pi over 2. We always, whatever we're talking about, if we're talking radians, then our reference angle is in radians as well. Yes? No, never. Because we never have a negative triangle. Make sense? Okay. Now, are you ready to do this on your own?
Yes.
I'm going to give you this cheat sheet. Because really, in all of this, in everything we do until the end of the semester, it all works off that first quadrant. Everything else in the circle is just working off that first quadrant, right? Okay, so I'm going to have you guys go ahead and take this quiz.
What? And you said we're going to take the quiz.
So I'm going to pause this. So each one of these is going to be worth 1 point, so there's a total of 32 points. All right, Sandra, put it away. All right, no, this is going to be part of the test. So I have 0 degrees and 360 degrees. I'm going to go by 30s. 30, 60, 90, 120, 150, 180, or 18, 21, 24, 27, 30, and 33. I'm not even going to label my 45s yet because I don't want it to be too crowded while I do my pi over 6s. So I'm going to do my bow ties. My bow ties are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now I'm going to do my butterflies. I might as well leave my butterflies in the same color. Yes? Pi over 3. 1 pi over 3. 2 pi over 3. This is 3 pi over 3. Oh, I never put my pi here. Let's put pi there. 3 pi over 3. 4 pi over 3. 5 pi over 3. Everybody's filled out now, right? Oh, pi over 2. I should have done this in green. Pi over 2. 3 pi over 2. And this one, we'll make this one in red too. Can I finish it and then I can answer it? Awesome. All right, I'm going to make my 45s in orange, so it's a slightly different color. Because we're done with all that, right? I didn't miss anything? Oh yeah, I did. Slack, and this is 0 pi and 2 pi. Okay, so now in orange, 45 degrees. 135. 225. And 315. The reason I leave the 45s for last is I think the 45s are the easiest. So I might as well just not crowd my picture. Does that make sense? And then I'll do in green, this is going to be pi over 4. And that's pi over 4, 2 pi over 4. This is 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4, and 7 pi over 4. All right, I'm going to go ahead and collect those. Fun. So what we're going to do is we're going to go back. I'm not going to add too much to evaluating trig functions. This is kind of what we're doing today is kind of like the backside of what I gave you yesterday. I just thought that this little more that I have to give you is enough where I just didn't want to give it to you yesterday. It just needs its own day to talk about. And the reason is because it's kind of contrary to what I taught you yesterday, but I'll show you right now that they both relate. Okay, Fidel, I need you to not do that. Thank you. Okay, so we're going back to the Ferris wheel, and I'm going to show you where, now what you've learned, you'll understand why we get that sine curve. Okay, so let's say I had a triangle like that for 30 degrees. What if my hypotenuse collapsed? What would that look like? The whole thing just collapsed. Like my triangle just collapsed. Like this part right here just gave out. What would happen? It would be flat, right? It's just like this. It'd be flat. Let's make this blue. It would be blue. Sorry, it would be flat. Blue and flat. It's Friday. It's almost the end of the day. I want to look at this. Okay. So when we did circles before, sorry, when we did triangles yesterday, what's this side of my triangle? What's the value of it? Sebastian, I just love when you throw numbers out at me. This is the smaller leg. It's 1. What's the hypotenuse? And what's the longer leg? 3. Thank you. What? We're not, don't even worry about that. I'm not doing that. We're referencing what we did yesterday. Okay, I've told you all along we're talking about a unit circle. I'm going to tell you right now, this is not a unit circle, this is a 2-unit circle. Why would I call it a 2-unit circle? So simplistic, guys. Because the 2 of that hypotenuse is my radius, right? So isn't this a 2-unit circle? Right? It's a 2-unit circle. Okay. So I don't know if I want to go forward or backwards right now. Let's just, okay, so this is a 2-unit circle. I want to talk about a 1-unit circle. All right? So a 2-unit circle, if I had a 1-unit circle, wouldn't that just be like half of it? Does that make sense? I kind of want to move. I come up with these ideas and then I don't do them in the other class. I feel bad. I feel like they're the stepchild. Right? Because this is a good idea, because I didn't do this in the last class. Okay, so if that's a 1-unit circle, what is the hypotenuse? 1. What would this side be? A half. And what would this side be? Root 3 cut in half. Right? Does it make sense? Everything's cut in half. Okay, that's where we're at right now. I'm going to show you in a minute how if I were to do the whole SOHCAHTOA thing, no matter if I use a unit circle or a 2-unit circle, they're both going to give you the same answer. Right? Wouldn't they? Because it's similar triangles. They're always going to get, they've got the same ratio. Okay, so let's go back to here. And yesterday we just talked a little bit about the fact that this is my x and this is my y. So we know cosine is x and sine is y. Correct? We talked a little bit about that. Alright, so if I'm at, I don't like this x here. X just stands for a variable, right? Well, when we're talking about a unit circle, we're talking not about a variable, we're actually talking our variable is an angle. Sometimes when I'm talking about x here, but we're talking about an angle, I don't want to confuse the two. So if I was at 0 degrees, an angle of 0 degrees, that means I'm flat right here, correct? It means I don't even have a triangle. But if this is a unit circle, what's the value of x there? If this is a unit circle, think in terms of a radius. How long is that radius? It's a unit circle, not a 2-unit circle. It's 1. So if I have 0, oh, I'm sorry, we're doing sines. If I'm here at 0, what's my y? Right? Y is 0 when I'm at this point right here. Y is 0. What happens when I'm at pi over 2? What's y now? It's a unit circle. So when I'm at an angle of pi over 2, I'm going to be at 1. When I'm back over at pi, what's y now? And when I'm at negative, or I'm at pi, 3 pi over 2, when I'm here, negative 1. And when I'm at 2 pi, 0 again. So now you know where that comes from. Right. Yep, exactly. So go ahead and copy that down for your notes. Okay, let's do cosine now. So cosine's here. So we're going to do the same thing. We're going to go a lot faster. So if I'm at if I'm at 0 degrees, right, my value of x on this circle is 1. So it starts here. If I'm at pi over 2, what's my cosine? What's my x value? 0. Making more sense now? If I'm at pi, that's this, that's -1. And 3 pi over 2? 0 again. And 2 pi? 1. It's just switched. So that's what a cosine curve looks like. Cosine curves always start at 1. Sine curves start at 0. Tangents like the slope of the two. Tangents look like this. Or I'm not even drawing it right. Like this. Kind of. No, we're not going to do this. All right, we're ready to move on? Okay. So now I will kind of want to show you, so let's play with these a little bit. What's sine of 0? Think of 0 degrees. That's why it's called a sine wave. So what's sine of 0? How high am I on the y-axis right now? Gosh darn it. Now do 1. Okay, so sine of 0, how far up or down am I on the y-axis?
0.
0. Sine of 270, where's 270? Way 9 times... -1. Cosine of pi over 2, here's pi over 2. Cosine. Because it's x. No, cosine's x. Cosine is x. A sine is y. Sine y. Cos x. Okay, ready? All right, let's talk about this now. So let's take the sine. All right, I'm going to do it in the blue first. Let's take the sine of 30 degrees. Sine of 30 degrees. The way I showed you yesterday was sine is so, correct? So opposite is opposite over hypotenuse. The blue, what's the opposite? No, we're talking the blue. What's the opposite?
1.
Opposite? 1. And hypotenuse? 2. Okay, that's what I taught you yesterday, right? If I switch it into the inner circle, into the unit circle, I'm still going to do sine of 30, which is still so, which is still opposite over hypotenuse. What's my opposite? 1/2. And what's my hypotenuse? 1. Isn't that just the same thing? And here come the text. Okay. All right, so we're not going to work too much with this, but this is where we're heading. Okay, so I just want you to know, because it didn't make much sense for me to say that this unit was 1 when really it's been 2. We've been talking, you know what I mean? The radius of the circle's been 2, but I just wanted you to show you that they're the same thing. It's just, it's a similar. Okay. So if I were to change these units, I would just divide everybody by 2. So 2 divided by 2 equals 1. Root 3 divided by 2 is root 3 over 2. And 1 over 2 is 1/2. Similarly, I'm not going to divide by 2. I want to turn this into 1. What could I divide it by? Itself. Nice job, Sebastian. I'd have to divide by root 2. So if I divide that by root 2, this has to be divided by root 2, and this has to be divided by root 2. Let me just show, not too much, but let me show you where this is going. These are actually coordinates around the unit circle. So check this out. This is an actual coordinate on the unit circle, and I told you that this side is x, right, or cosine?
Yeah.
Cosine. And this is y? Sine. Okay? Kind of like, I don't want you to understand it completely. I'm just trying to like sprinkle a little bit of thought into your brains right now. Or, I know these are cool, right? Look at this one. Alright, so we're going to be looking at coordinates now, y over x, which y over x is actually tangent, which is that line right there, okay? Alright, let's do it. This is just basic review. Negative pi, 5 pi over 3. Let's see how much time we have. Okay, so tangent, negative 5 pi over 3. I'm going negative, so I'm going in this direction, right? So it's pi over 3, so this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. That's negative 5 pi over 3. I'm going to erase the rest. Down my angle. What triangle is that going to be? That's a 60. Right? It's the tall one. So that's 60 degrees. So let's evaluate that trig function. Okay, so we've got tangent, which is TOA, which is opposite over adjacent, or y over x. You could look at it either way, right? Isn't the, okay, first of all, let's label it. This side's 1, this side's 2, and this side's root 3, or 1/2, root 3 over 2 and 1. Either way you can look at it. So this is going to be my x, sorry, my y is root 3, and my x is 1. Or my opposite's root 3, and my adjacent is 1. So this is root 3. That's the answer. Just like yesterday. It's just like yesterday. Same thing. Only you're going to have some of them, they're going to have those 90s and 270s, which I just taught those to you, right? If sine is up here, what is that? 1. If sine is down here, if cosine's over here, negative 1. If cosine's over here, cosine 1. What if sine is here? What if sine is here? What if cosine is here? Cosine? Cosine? Okay, you guys got that. Try that one. Alright, so I have sine of pi over 2, so I'm going to go to pi over 2, which is here. Pi over 2 is not a triangle, right? It's a straight line. Does that make sense? If I'm at pi over 2 and I have to go to the x-axis to draw my triangle, guess what? That's not a triangle. It's just a straight line. Its sine is y, so it's 1. Okay, look at it this way. Aren't the coordinates of this point right here 0, 1? Aren't the coordinates of this point 1, 0? Negative 1, 0? And 0, those are the coordinates. Make sense now? I still don't know. I can't see your answer. Oh, +1?
This was just one.
You have a slash on it, so I didn't understand it. Yeah, you're right. Okay, so I'm going to end it here. You guys did a good job.